Good evening, everyone. It's really a pleasure having all of you here, and thanks for the participants for joining us to our Spatial Analysis and Simulation Lab Community webinar series. Our lab is a multidisciplinary research hub dedicated to exploring the intersections of architecture, urban design, urban planning, computer vision, and spatial analysis. At the core of our work is using advanced simulation and analytical tools to uncover behavior patterns in open spaces, providing innovative solutions for urban environments. Our research focused on spatial analysis, cutting-edge computational techniques to study human-environment interactions, optimizing urban design, and improve public spaces. Through this webinar series, we aim to share insights from our ongoing projects, foster collaboration, and engage with a global audience interested in the transformative potential of spatial simulation. And as you can see here, this is our website, and this is our research interest and our previous webinars that being conducted with very famous scholars and workshops that we are doing and other simulation outcomes like having some sort of an open source program or even automation issues. And I would like to thank you for joining us today, and we look forward to an engaging session and hope this series inspires meaningful discussions and advanced in the field. In the light of our lab's commitment to integrating advanced spatial analysis with innovative urban planning solutions, we are delighted to transition into today's central discussion by highlighting the pioneering work of Professor Meta Pont. Now, please allow me to present a concise overview of her distinguished academic and professional journey. Meta Pont is a professor of urban morphology and urban design at the Chalmers University of Technology in Gothenburg. She leads the research area of a Spatial Morphology Group, which is engaged in research in urban morphology, Spacematrix, and design theory. Through primary analytical and quantitative methods, properties of built form are described, and its significance for peoples and other species as well. Use and experience of the city is investigated. Besides proving evidence of how the built environment affects urban life, the group also develops tools such as the PST and urban calculator to support design decision-making. Meta has published the book Spacematrix, Space Density and Urban Form in 2023, where the concept of density is critically examined. The book specifies the relationship between density and urban form and the environmental, economical, and social effects of density. In addition to research, Meta teaches urban design and is an examiner for the design studio socio-ecological urbanism. We would like to thank Professor Meta for her joining us today, and with a great pleasure, now invite her to take the floor and share her invaluable insights. Thank you very much for being with us today.
Great. Thank you, Nabil Moreb. First of all, for inviting me for the webinar, and then for your kind words introducing me. So I think I will just sort of get into it and give you an overview of the work we do. So I will share my screen. And in case there are, let's say, questions of sort of that you really would like me to ask immediately, maybe Nabil, you can look at the chat and sort of call out, let's say, if there is a question that you think that should be addressed immediately. Otherwise we can take them in the end. So what I will try to do today is to really sort of talk you through the work that is done by the research group SMoG, with a focus on how to support actually the practice of urban planning and design through the work we do as researchers. And I started my sort of journey as a researcher by measuring density, and I came across, let's say, this is a quote from Anne Moudon, that measuring urban form is actually a way to empower architects so that they can then perform their art with the precision required. But I have jumped into many discussions about that quantification of an artistic profession as architecture is impossible and we shouldn't do it. So I always bring this quote with me because I actually think this is the reason. That's actually why we do need to quantify urban form. So you will see that throughout the work that we are doing is all the time, let's say, trying to sort of see this as a support. Also, the tools are support to, in the end, be able to work as an architect, which also is a creative profession, of course. It needs creativity and analytical knowledge to actually create the urban environments that address all the challenges that cities have today. So that's the reason I bring this. I also bring always this overview because, of course, you don't work as a researcher alone. So me as a professor leading a research group, I need all these people, let's say, to do this with me. And we need to sort of engage in webinars, in conferences, etc., to actually build up this huge body of knowledge. So that's the reason also I'm very happy, let's say, always to sort of engage and be present in invitations like this. Then I always have this, we don't talk about it. It's the funding acknowledgement of the things that I will show you, the latest ones. But let's go into it. What I will try to do is to have 3 themes kind of throughout the whole talk. It's about modeling. And then what I mean with modeling is, let's say, how do we represent actually the built environment? What kind of indicators, measures do we have? At which scales is it relevant? And I will talk about evidence. So to validate our models, what do they tell us? And then I will jump into the tools. And I will do this kind of, it's not, I will do some loops, let's say. So the tools do not come in the end, they come while I'm going. And these we need both to do, let's say, the analysis for research, to do statistics on the relation between models and evidence. But I will try to focus quite a lot on the design support tools. With the ambition actually to reach all the way from doing the evidence, translating that in knowledge that is actually applicable and useful for practitioners. And this also goes into the tools. It requires something else from a tool to do that than a tool to be only a support for a researcher. And I will talk a little bit about that. And in our group, we navigate between these 3 huge topics. And what I also will talk about is to broaden the field of urban planning and design to be able to understand conflicting impacts. And I will talk a bit later about this. I will not explain this graph, but just that you know, let's say. So I have a view on urban planning and design and a responsibility for urban planning planners and designers that goes beyond what we thought was our core business. And that's the reason that Nabili also announced me, let's say, that I look into the movement patterns of people, but actually also of other species. So I bring in ecology, let's say, at the same level as the social aspects of cities. But I will talk more about that later. The global challenges, I will go very quickly because you all know, let's say, we face huge challenges that have, I think the work of Rockström and Raworth are key here. Let's say they talk about kind of a responsibility to create urban environments that make that people can thrive in those environments, that are healthy environments, but we also have to take care of that we don't cross planetary boundaries. So both the planet and the people and all the species have to be healthy. And this is a huge challenge and partly on the table of urban planners and designers. And especially because we have an enormous urbanization trend, this becomes even more important. So the cities might be part of the problem, we know, but they should also become part of the solution because people move into cities. So we have to tackle this. And as was also said by Nabil, that I came into, let's say, my first research publications, let's say, they were about density and densification. And I have studied this ever since. I still publish, let's say, on this topic. It's a key topic. We have these UN Habitat planning principles for sustainable development is actually saying that we should have a minimum level of density to get there. We have studies since the 1980s, 90s that say that to tackle transport issues, so that people walk more, that they use public transport more, that we have less emissions from transport, density plays a crucial role. That's the middle image you see here. And we also know of studies that actually cities are not densifying, they actually are sprawling. And they have been doing that for many, many years. Some cities do not, but in general, all over the world in the last 100 or few hundred years, they have been sprawling. So we have actually less density. And this is a trend, as you see in the right picture, everywhere. And I looked into the impacts of densification because, yes, we know that it has a good impact on sustainable transport. But actually, as you see here, the yellow bars that go down, it has negative implications in terms of ecology, in terms of social impacts, and in terms of health. So we have to deal with this. It's not either or. We have to sort of, it becomes not a question if we should densify, it's the question of how we should densify. And then our role as urban planners and designers becomes very, very crucial. I skipped this one. Well, let's not do that. The image below, as I said, I always try to bridge, let's say, from doing research to what happens in practice. So what we did here, we compared the evidence found in more than 200 papers on the impacts of densification. That's the upper diagram. To the how practice talks about this, which arguments do they actually use? And when the bars go in the same directions, they go up, then actually they are in, they say this, so what we know from research is the same as what is argued for in practice. But you see in the ecological, in the social impacts of densification, there is a huge discrepancy. This is important. So somehow in practice, they claim, they argue that through densification, we create better places for people. It's good for well-being. But actually, research says, no, we don't really know. So these are important messages, let's say, to practice. Another message or another sort of result that we found through this systematic review that I did is that the way we measure density is rather crude. It's very, very. So you see here, 63% of the papers use population data, which most often is on a census tract level, which we know from an urban morphological perspective is not very, very precise. And I will get back to this. Only 17% use more advanced morphometrics. So this is a task for those who model cities, how we represent the city. Do we just grasp the easy available data? Or should we actually do it in a way that it becomes informative for urban planners and designers that actually do not plan population density, they actually plan buildings and streets, etc. Another thing that sort of comes from this sort of, I fly you in, let's say, why I do the things that I do. So we had this paper already from the end of the 1980s, that proved how important density is for sustainable transportation. And we have repeated this study like, I don't know, hundreds of times, and we find the same thing, so it's very clear. But what we also saw from this overview was that actually all these negative impacts might have to do something with the greenery in cities, that is disappearing because of densification, etc. So that's the reason we started to include in our models the green and blue infrastructure layers, and started to also wanting to go to understand biodiversity, quality of green, etc., etc. So that's the background of why I broaden the perspective. So here's the triangle that I showed you in the beginning. So what we do here, this kind of the research agenda of the SMoG group. We have studied both the role of spatial form on social processes for many, many years. And not only we, many have done. There's also a lot of studies done on the impact of spatial form on ecological processes. Think about urban ecology, urban climate studies, etc. What is less so done is actually this interaction between the two, where urban form, spatial forms plays a crucial role. So that's where we are. This is kind of really on the forefront of the research that we do in our group. And we want to understand the interaction between people and fauna, which is an important social ecological phenomenon. It provides benefits for people, health and well-being, we know from earlier research, but also disbenefits. Let's say if animals and people meet, there can also be, let's say, injuries, diseases, etc. And if the more compact we are to, let's say, live together, this becomes more severe. The pandemic is an example of that in a way. Also, humans can be a threat for species and biodiversity. So there are all kinds of interactions going on. And we don't know so much about this, actually, especially not in cities. So that's what we are, where we are. So now you get the big picture. So this is kind of the big framework, why we do what we do in our group and the way we approach this. And I will sort of dive a bit deeper now. To do so, to give answers, we do three things. We develop models. We could call them digital shadows or digital twins, whatever name we give it. Let's say different levels of sort of advancement to represent the built environment in a meaningful way for urban planners and designers and architects. This is important. So population data, can we do better? Question mark. The second thing is to get evidence. And then we always, in our group, will always look at the social ecological phenomena at the same time. We don't sort of put them aside. Let's say we want them, have them both in our models. And then we want to develop rigorous methodology to inform the design process. And here tools come in also. And that's the reason I sort of highlight this a bit more. With the aim, let's say, that the design process will actually be sort of informed. We could call this an evidence-based design approach, where you have a design proposal that is evaluated through these tools and the evidence that we come up with to then revise your design proposal and do this design loop over and over and over again until you reach the objectives that you were aiming for. This is not the way in general practice is working today. So this is, I mean, this is a huge sort of, this is not simple. We need many people working on to sort of to support this new approach. I will my final slide in this talk will be about that a bit. I do so so we apply all this already in the design studio that I examine at Chalmers, which is the Social Ecological Urbanism Design Studio. We make master plans where we rigorously go through this design loop with having ideas, analyzing their proposals, see how they fulfill their aims, and then they go on and on and on. Using both, let's say, the social and the ecological impact assessment simultaneously. Then just a short note, let's say, evidence, let's say, so I'm kind of propagating an evidence-based design approach for urban planning and design, which is not so common. It's very common in medicine. It's common maybe in sort of health architecture. It's a bit more sort of established there, but not so common in urban planning and design. And here it is important to see, let's say, to sort of to demystify this a bit. What is evidence? I always talk about these different levels of evidence where we in research aim for the highest level of evidence, let's say where you actually have control groups and control variables to sort of really know how does density impact health? What other things play a role? What part is density doing? So we have to be precise there. While actually practice is still very much working with a very low level of evidence, it's still evidence with a very low level, which is best practices, precedents, etc. So I want to move, let's say, the bar to higher level of evidence in a way, so that it's not completely different from what we do, but we just want to move the bar to high level of evidence. And their research comes in and can provide that. Now let's see, how do we model then? How do we represent the built environment? And to start with, it's good to sort of put forward that urban form or the built environment is not a neutral background. It's actually the instrument that we have as architects, planners, designers to make a difference. So this is what we have to master. So we have to know how is density impacting? How is street centrality impacting pedestrian movement, for instance? So here the work that I did on density comes in, where I developed, which is described in the book Spacematrix that was mentioned already earlier. So what we did actually there is to solve this problem that was described much, let's say, a long time ago, that saying that, yeah, density is a bit of problematic because it has such a weak relation with building types, with urban form. So why use it? It's just statistics. And I was like, no, this cannot be true. So I started to dig into this and to see, can we make a relation between urban form in more qualitative terms, and can we quantify this in a meaningful way for architects? So then it has to be linked back to building types and urban and let's say more qualitative aspects. Otherwise, it's meaningless for an architect or urban designer to work with. So this is what we developed, Spacematrix. This is one of the earliest sketches where we just put a lot of examples in a diagram with a set of variables, and I will walk you through. So what it in a way is it's instead of defining density with one variable, you do it with a set of variables. It's as simple as that. So to distinct these two areas, which I think we can agree they are very different in all kinds of ways. But they are highlighted in the diagram here. They have actually the same floor space index or floor area ratio. So you could say the same density. This is the way we normally express in planning density, floor space index or floor area ratio. But that's a bit problematic, and indeed sort of confirming this statement that, well, there is no relation between density and urban form. You see, doesn't work. But then we started to add other variables. We added the coverage of these buildings, and the upper one has only 10% approximately of the land is occupied by buildings, while the one on the bottom has almost 50% is occupied by buildings, which is the measure of ground space index or coverage, or what we could call it. And also the height of the buildings is very different. I mean, we can see that, it's clear. And these things are mathematically, it's not rocket science. This is kind of simple. These are related to each other. So you can put them nicely in this diagram, and you capture with one point, you describe all these variables at the same time. And then we started to fill this model, we could call it. It's a more think model with all kinds of examples. And what we also saw, they clustered. So similar typologies, they cluster in the diagram. They have similarities in FSI, GSI, building height, and another variable that is open space ratio. I will not go into detail there. And we found, let's say, this more modernistic, spacious neighborhoods. They fell into the same place, etc., etc. So we found kind of a pattern in all the examples using this model, which is called the Spacematrix, and is, I think, used. The book is 2023, but it's a revised version, so it was already published in 2010, actually, the first version. But we add chapters and we revise and we do a lot of stuff. So it's still worthwhile to check the latest version, which is actually also open access. But the model, as we developed it in the beginning, is actually scale dependent, and you have to define areas, which is very, very time consuming and hard to do. And you have this modifiable area unit problem. So there are a lot of methodological issues with this approach that we developed in 2010 already. So what we did, we moved from this to an approach that is based on accessibility. So instead of defining density on a plot level, a block level, a neighborhood level, we said, no, let's do accessible density. And then you define it on an accessible catchment area of 5 minutes walk, 10 minutes walk, 15 minutes walk, etc., etc. Far before the 15-minute city model was launched. And then you see the difference. It's also, let's say, it's also in terms of understanding urban life, very important, because on the right image, you see a similar neighborhood analyzed through accessible density. On the left, you see area-based density. And you see a plot here on the left with a high plot density, but a very low density neighborhood density on the right side. So suddenly you get another understanding of this location. Yes, it has high plot density, but actually it's located as such that you cannot expect many people actually visiting this area, only the ones living there. While number 2 in this image has a low plot density, but a very high neighborhood density. So this becomes interesting. And we know from later research that actually the one on the right is much more, it has a more powerful prediction of all kinds of economic activities, pedestrian movement, etc. Another huge sort of advantage of this method is that you can start analyzing whole cities, regions, countries, because you can automate this process. So here you see Amsterdam using the same methodology but automated. So it's you do the accessible density analysis, then you run a cluster analysis, and you put the results back on the map. And this map is a combination of both building type and density. So it's both quantitative and qualitative. And we have sort of applied this on many cities all over the world. And you can do comparative studies, etc., etc. The same we have done for street typologies. In this case, not based on different variables, but on one and the same variable. It's a measure of centrality, more specifically between the centrality, which is used in space syntax research. And what we did here is that we looked into the profile of each street across scales. So the typology that you see here, the city street, for instance, in brownish colors, is the street that has a general high centrality across the scale, and it gets higher and higher and higher the higher scale you get. While the local street, which is the bluish one, has a very high centrality on the local scale, but then it drops. So this is kind of describing each street in terms of its role in the system on all different kinds of scales. So it's a very powerful way of describing. Otherwise, we needed like 10 maps and look at all these maps and try to figure out what's going on. But this is a very sort of simple way, in a way, to sort of showcase what is the foreground network, what's the background network in each city. And also this we have automated. So I put here one of the, so that we did the same for the density types. It runs in the core is the place syntax tool. I will talk a lot about that a bit later. We have developed that one at Chalmers in collaboration with some other universities and other people, but we have done a lot lately. But then there were Python scripts that sort of make that the whole workflow is automated. So getting the data, cleaning it, filtering, etc. Then it goes to PST, you do the centrality analysis. Then it goes to Python again for the statistical clustering analysis, and then you have an output of these street types or building types. So here are some images of all the let's say some of the steps in between. So here you see all the different centrality analysis that are combined into, we do first a PCA and then a cluster analysis. and all these results. But the whole process, it's like it's really, I mean, sometimes I feel like a professor says, you just push the button and then it runs, but actually this one does mostly. So we have a new city and we can just run the whole process. And here we have done, let's say, a few new cities recently in another research project. Okay, then we have a nice model. We have an advanced way of describing density and building types. We have an advanced way of describing street typologies based on multiscalar centrality. What does it tell us about how the cities work, how people use them, etc.? And then we work with the theory of natural movement, and I think most of you will be familiar with that, but in a nutshell. So it says that centrality, so the configurational properties and attractions, and we focus on density in this case, are both important to understand pedestrian movement and co-presence. And between pedestrian movement and co-presence and the attractions, there is also what we could call a multiplier effect. So what it says is that if we have a high centrality, the probability of more people being co-present in the same public space is high. So that's this arrow going down. It will also influence this high centrality out of an interest to invest in those places. So attractions will be more, the density will be higher. Higher density is also sort of giving more people, let's say, it has an effect that more people will be there. And if more people are there is more interest in other land uses and density. So this is when it goes up and down, the multiplier effect. And this in turn, this pedestrian movement and co-presence has enormous implications for all kinds of socio-economic processes. Segregation, gentrification, economic clustering, etc. And there's many studies done, let's say, by many different groups all over the world. So this one, we said, let's do a proper big scale test of this using our models. So what we did is that we went to these 3 cities, Stockholm, Amsterdam, and London, and each city we went to 20 neighborhoods, and in each neighborhood we measured like 10 streets, the pedestrian counts. So we just counted and wanted to see, does this theory apply for all kinds of neighborhoods, from high to low density, from villa areas to very CBDs, etc. We used Wi-Fi signals to do this, and it's let's say we talk about advanced modeling and digital, etc. But in the end, you just have to be also sometimes do the let's say the hands-on work and be there and put these boxes out in the streets, etc. And we found that here you see the diagrams of the density types and the street types, and we saw a clear pattern that the more dense and compact types have a higher flow of people in the streets. And also the streets with this, we call the city street, what I call the city street, with the high centrality, especially at the highest scales, have more pedestrian movement. And actually in combination, we found that it's even more predictive power. So when we did, besides this ANOVA, we did a regression analysis, and we found like 65% is explained by just those 2 variables. And then we took this, and I could, let's say, there's much more to say, but I just put this here. You can read the paper if you're interested. We took this knowledge and said, okay, can we go one step further? Can we, based on the model in one city, so and the validated model in one city, Stockholm, can we train our model there? Can we then predict the streets in Gothenburg? And then we had data there of real observations to see how well we did. And we arrived at the 55%, which is not extremely high, but on the other hand, with just 2 variables, it's pretty good. And I will get back later a little bit about, let's say, what kind of knowledge do actually urban planning and design, what do they need? How precise should the information be? Or let's say the prediction be in this very early stage of a design process. where you don't know exactly which shops is going where. So all these very advanced models with a lot of data, you cannot use them because you don't know yet. But often density and street typologies, you know. So based on that, you get a first hum of an indication of the distribution of flows. So besides the regression we did, we also looked at actually the distribution of the flows. So not the exact numbers, but just where do we have many and where do we have few? Because that's the most important, because based on that, you can start to decide, okay, along this street, we should actually plan active ground floors for shops to be. Here we shouldn't, because we cannot expect a lot of flow. So that's the way we went about. Let's go to the tools now. So what did I use for all this? And as I said, let's move this, is that to do this, and I'm still only looking at pedestrian movement and co-presence, the tool that we use is PST. It stands for Place Syntax Tool. And it is actually doing what most space syntax tools do. There are a few out there, depth map, and there is another package for GIS. PST is a plugin to QGIS. And on top of these sort of more common space syntax values, it also adds attraction. So you can do attraction betweenness, you can do attraction distance, you can do attraction reach. So it combines, let's say, both the attractions and the configurational measures, which in the most of the space syntax tools are not included. So the attractions are ignored, kind of, and we know they are actually very important. So that's what space syntax does. And I think, so in a way to do these street types, you can use PST to run all the analysis. Then you need in addition to do the clustering. But PST does the street centrality indicators, which is an indicator of the flows of people. That's what you can do in PST. And it does at multiple scales. So you can run all these scales. You can run them at the same time. So you just put them all in and you get all of them in different tables. It does, of course, also the accessibility and proximity analysis, where there are actually a lot of other tools out there, but in this case, you can use on the same network and you can run them very smoothly. And you can do, which is a bit different, you can choose how the distance is measured. Of course, straight line, like always, walking distance, but also number of turns, which is central to space syntax, and the angle deviation. So you can do a bit more, which links to the theories that are common in space syntax. So these settings you can have in the PST tool. And then you can get these nice maps. And then what is actually important, I wanted to highlight here, is that we also developed a functionality that is called create segment maps. And I have to go step a bit back and to go to the sort of the origin of space syntax. As some of you might know, that the origin is that you had an axial map. And an axial map comes from the theory that actually how we navigate the environment is not stationary, but we actually move through, and then the angle deviation and our sight lines matters a lot. So what they did in the axial map is that they actually drew the whole street network, you could say, by hand, by drawing the least amount of straight lines that cover all accessible and visible space. This is a hell of a job, especially if you want to do many cities or regions. This is impossible. So the whole field has moved to use actually road center line maps, which you can just extract them from from OpenStreetMap or other sources. But then there might be issues doing that, because you lose this theoretical foundation of how we navigate through space and what makes it actually that space syntax was so powerful in predicting pedestrian movements. So in the PST tool, you can take the road center line map and create a line segment map automatically. Let's say the whole cleaning process is done for you. And then it creates this graph. They look very differently, but actually they are not so different. The axial map this long road, CDE, is one node in the graph. And then to go to the road AB, AB is, and then CDE is one step. So you take one turn, which is counted as one step. If you go here from C to A, it's also one step, you see? If we go from C to D, it's 0. So although it looks complicated, actually we put 0, so it becomes like an axial line. So in the graph, you actually take care of the differences in representation in the beginning. So we mimic, so to speak, the axial map. And this process is automated in PST, so you can very easily sort of your road center line map is prepared to do this kind of analysis, because you cannot just run it without doing this preparation. So you have to go through this step of creating the segment map, otherwise you get very weird results. This is the cleaning process. You can read a lot in the documentation that we have. But what I wanted to highlight also is actually that when we have this, we can start to do other interesting stuff, because we could also so I have to maybe say that in this line segment map and the analysis that we do, it's the angle deviation that counts. So the difference between F and G is exactly the, let's say, the angle deviation of that turn, while in the axial map it would count as 1. In the axial map, you didn't care about, let's say, if it was a 90 degree or a 16 degree, it was all the same, it was all one step. A bit crude, you could also say. In the current, let's say, what is mostly used currently, it's very precise, but actually we don't know how we as humans understand the 16-degree angle deviation. Do we actually notice? Do we see it as an angle and a change in direction? Or so there have been a lot of different models that actually what they do, so you have the continuity maps, the natural street maps, all these concepts that are out there. And they look at this, they sort of define what is significant angular deviation or a change. And actually in the PST, there is an experimental tool where you can start elaborating with this. So you can put this angle there, and then what you get, it changes the graph. It doesn't change the representation, it changes the graph. And that allows you to, for instance, test all these models against pedestrian movement observations and see which model is actually the best. And we have done that. There is a paper that I put here where the 20 degrees below that, we don't really, the model performs worse. So we can actually ignore them. So we could actually put the 20 degrees and then it sort of, it gets even closer to the axial map, you could say, because in the axial map we drew them, that we actually, we didn't draw the 16 degrees. We actually, often it became one line. So this is kind of a way that we as researchers can become very precise in how we actually represent and model the built environment. So check it out. Not so many have used this. I think a lot of more research has to be done to really sort of come to a conclusion here, because we have done one study, but it needs much more. The last thing, the latest thing that we have added is change maps. So the before and after analysis. So you can just, you run your analysis in the PST, and then you ask them to sort of also give you a map of change, and then you get kind of a heat map like I show you here. This is very recently added. So I think not even the documentation is out there. I think it's already included, but we didn't publish the documentation yet. And it becomes really interesting. So we have used it in a few studies, in this case about cultural heritage impact. And what we actually looked into here, so in blue, the centrality goes down. So we can expect less people to take that route. And in red, the centrality goes up. And here you see this where it's blue is actually an old commercial street from the medieval times. And they are making all kinds of changes in this very small town. They made new crossings, you see here. So let's say this street we have over here is this one here. And it's currently kind of a very heavy trafficked road. They want to make it a city street. Nice, everybody thinks, good idea. So they make a lot of new crossings, but actually what happens is that it will attract a lot of movement. And the old street that has all the shops currently will probably lose them. So this gives sort of insight in, okay, this is maybe from a socio-economic perspective, a good change, but from a cultural historical perspective, maybe not so good. And this at least puts it on the table. Then a decision has to be made. What do we do? Here is the link to the GitHub and all the documentation and etc. As I said, we want to broaden, so I should jump into how do we do that? How do we get the ecological perspective in? And our main research question is, in a way, can we build denser without jeopardizing biodiversity and human well-being? That's kind of our overarching question we want to sort of tackle with this. So we have this, I showed you already. What we actually do, there is a similar, well-developed theory about the movement of different species. And I put it on the right side. It's fantastic how it sort of almost does the same thing. It looks at habitat quality, kind of you could say like attractions, but then from an habitat perspective. And it looks at habitat connectivity, a bit like centrality and the configurational perspective in our sort of conventional way of looking at cities. And what we do, we make a model where we put all of these at the same time. And the habitat quality and connectivity, we know already, others have done that, has an enormous impact on species mortality, mobility, diversity. And that has implications for ecological processes in the similar way as I just informed you about, let's say, how accessibility, centrality, and density have an impact on pedestrian movement, which on its turn has an enormous impact on socio-economic processes. So we combine all these layers together in the model to understand the combined impact. And of course, I mean, this is also forefront. So we started like 10 years ago on a more theoretical level. 5 years ago, we made the models and now starting to add evidence. And so we are in the middle of this. So I don't have that much sort of evidence to show you yet. What you could do to just jump, let's say, what can practice do with this? Well, for instance, you could develop a tree planting strategy on the right side here, based on a model of sort of a simulation of pedestrian density, so how many people walk the streets, and the visual exposure of the tree canopy currently. And where you have very little in red tree canopy in view, so you don't see it, you don't have a sort of profit of all the ecosystems it could provide us with, these trees. And we have a lot of people walking, well, that's where you have a huge impact. So there we will prioritize the tree planting. So it's a very direct, let's say, sort of impact on practice you could have with this kind of combined models. And we developed a tool, was, I think, launched a month ago, and we published a paper 2 months ago with some evidence of how this works. So the tool is actually purely on the right side, the habitat quality, habitat connectivity, in its essence at least. But what we do, we include accessibility, centrality, and attraction and density into that model, and I will show you how. So this is the core to do a habitat network analysis. You know which biotopes you have, you put some parameter settings that has to do with different species. What you get out of that is a friction map. It's kind of a barrier map, you could say. Where are the barriers and where are the qualities? And those combined gives you a functionality map. But the friction map is kind of like the centrality analysis we do. It gives you the dispersal map. So how the higher probability of movement is what this map is giving you. This an ecologist could have done. What we did is that we actually add the PST input in the biotope map. And this is important because the streets and urban areas are regarded in this method that ecologists have in a very crude way. So a street is a street, doesn't matter how many cars or pedestrians are there, it's just a street. And an urbanized area is an urbanized area. It doesn't matter if it's high, low density, spacious, not spacious. They just thought, it's urban, which is very crude. And especially if you bring these models into cities, it doesn't work. So what we do, we add, let's say, our variables that we developed, let's say, earlier on in this biotope map. So in a way, we add biotopes, the urban biotopes, in a much more sophisticated manner. And this has proven to be very, very powerful in predicting the species mortality, species movement patterns, etc. And you get these kind of maps if you run the analysis. It's kind of heat maps of functionality for different species. Here's the tool. Documentation will be added in the coming 2 weeks, 3 weeks. I'm almost there, so don't worry. The last thing I want to show you.
Take your time, by the way. We are happy with you. Take your time.
Good. The last thing that I want to show you is that, this became quite complex, isn't it? I mean, I don't think any practitioner will run all these analysis, and you need high sort of understanding of the complexity of these models, the data, and it's a huge sort of effort. So to inform practice, simpler tools are needed. So we have also in the group worked many years, and this is ongoing work, on a tool that is called Urban Calculator. And what it does is actually that we use the same motor, you could say, in the background, it's PST, and this habitat network will be added later on also. So we use that as exactly the same motor that you use in QGIS, but the interface is very, very simple to the end user. So in our case, the urban designer and planner. And what they can do, they can start adding their scenario into the tool. And when you draw in the Urban Calculator, you can, it's impossible, it's almost impossible to do it wrong. It always snaps right. It's sort of, and we take care of the segmentation of the network, etc. All the things that happen in the background, let's say. And this we aim, or we sort of argue, is a very powerful tool for early scenario assessment. So you don't know so much yet, but you want to know the impact to minimize risk, controlling costs, improving design efficiency, etc. I think so. That's the reason. So it should stay rather simple, although the analysis we do are highly complex and advanced, but they are in the background. And what you then get is kind of also the output of this. So you do your things. You add a street or a bridge or whatever. Then there is an output that is also sort of defined by us. You get a before-after analysis. You get explanation of what it is. Sort of that to help you navigate. Let's say when you have this report, in a way you get a report out of the tool with all the different types of analysis and some conclusions. The model is built on a motorized, or the tool is built on a motorized model. So the street network where cars, motorized traffic can drive. But you also have a non-motorized, so the pedestrian model. We have both always, so that you can test your interventions both on both of these sort of models. And then there are all kinds of attraction data, density, but also, well, what the customer needs, schools, shops, healthcare centers, whatever is important for the area. Green areas, of course, as well. And then let's say here in red, you see that someone has sort of added some streets, and then you get the before and after analysis of the tool and its explanations. check it out. It's kind of, so we developed it in the SMoG, in the research group. Currently, it's an own company, so it became a spin-off company. And the reason is partly to be more fast in reacting what clients need, but also at a certain moment it didn't fit the research agenda anymore. It sort of the work we did there was not research anymore. It was sort of purely getting the thing out there. So we decided to sort of develop it as an own company.
So it's an open source?
It's not open source. So the motor behind is open source. So you have to buy a license. You get a 1-year license, and the client gets from us the license plus the data set. And then it's a checked data set. And the reason we didn't put it open access is just because of that. Because there's a huge risk that if the data is not correct, that the output will become not useful for the user. So if you want to, so that's the reason, let's say, for doing it like this. The client can also have its own data sets that we implement, but then even then we test it. There is a sort of a quality check that is done by the company. My last slide. So in a way, let's say what we do, and I didn't put, let's say, practice here. Normally, sometimes I also do that, but I thought I will end up right like this. So our research is focusing and still doing that. Let's say we are still developing, improving how we describe the built environment. We are adding more effort to also standardize this, to sort of describe, let's say, in protocols and in standards how to do it. This representation, let's say, of connected to data also, because we also want to sort of go back to the national authorities and say, this data you have to start collecting and do it like this so that it's useful for urban planning and design. So that's the sort of the ambition there. The evidence, we are moving on to do more longitudinal and post-occupancy studies, because we think there there's a lack of, and we need to get more of that is even better in so going to high-level evidence. Investing in systematic reviews, because we also need that. One proof is not enough. We need many saying the same things. And this tool development. This is also ongoing. Let's say there is lots of work to do. So we work a lot on these 3 levels. Of course, on the theoretical level as well. That's sort of an overaching thing that sort of feeds in all 3 of them. From the education perspective, I thought it's interesting to highlight that, because what this needs, if we want to support an evidence-based design approach, well, first you need to find the evidence, which is not easy for students. The systematic reviews, for instance, and the meta-analysis are a way to do that, because you don't need to read everything. You just read this systematic review overview paper. So that's one thing. But also the students have to be able to critically evaluate the quality of the evidence. They have to be aware. So this requires something that our education, at least at Chalmers, doesn't have today. They take something and like, now we have evidence, and they just go with it. They run with it, one paper. So this is something that is really needed. And the use of spatial analysis to evaluate the scenarios, to make the evidence place or context specific. It's crucial. So GIS is a very important part of education. This is implemented. This is common now at Chalmers and many universities, I know. So this is already happening to a large extent. But I see these are the things, let's say, how we try to not only giving them our tools and our evidence, but there's also a need for a critical perspective and a critical ability. So let's say to know, what kind of evidence do I have here? How can I work with it? What kind of data do I have? Is it good enough? Is it actually is it representing the built environment in such a way that it is useful for me? There have to be, let's say, that kind of critical perspective has to be there, and there's some work needed in that direction. And here you have a bunch of references. Thank you.
Thank you very much. It's really, really, yani, I'm so happy that you are here with us and sharing your insightful, valuable research point of view. And I really thank you. It's a pleasure and honor having you
Mm,
here. And I'm going to have, I mean, the privilege of having the first question, but
mm,
please, everyone else, kindly write your questions in the Q&A or just raise your hand and state your question. And please try to make your questions a little bit brief and to the
mm.
point so we can just having more questions rather than just
Yeah.
having one or two questions. My first question, it might be a little bit a silly question, which is dealing with dynasties, because I was curious a little bit before about how much accessibility is needed for a city, and I might have the same question, how much dynasties do you need within the cities? Is there some sort of a threshold
Mm,
that you might say, no, don't have an over dynasty, otherwise
mm,
it's going to be completely negative and destroying the city? Because as you can see, most of the cities, even here in Africa or global south, they
mm.
are just expanding dramatically and
Yeah.
with huge densities. Cairo is over 20 million, so as a city. So do you have any thoughts about this? How much density you can measure?
Yeah, yeah, this is a very good question, and not a silly question at all, and and a difficult one also. Let's say from the review that I did, I found actually, but very few that looked in an advanced way on the impact of densification using not linear regression, but let's say looking, are there actually optimum, or let's say, is there, because some did, so that you have an increase in density to a certain extent is positive and then it drops. And then you could find thresholds, but are actually rather few that do that, have done that kind of studies. So it's hard to give you, and let's say that probably there is also not one number. Let's say I think it's also context dependent and culturally dependent. But I'm sure that there are, for some aspects, there are these thresholds actually. The other answer I want to give is that comes a little bit more from ecology and from resilience thinking, which also comes from ecology, which is now very common to talk about cities should also be resilient, etc. What is stated there is that we need a diversity to be able to handle unexpected, unknown changes in the future. And we know that a diversity is actually a good way to deal with that. Meaning, from a city perspective, that, well, we should, I mean, a diversity of densities, a diversity of centralities is probably the way to go.
So is it common between global north and global south cities? Is something universal, or do you think that the culture might just play a little bit of a factor here? If we really defining the diversity and how much diversity, because it's always about how much, like the inclusivity.
mm,
Everyone's saying, let's make the spaces more inclusive.
mm.
Okay, until what level?
Yeah, yeah,
Because
yeah,
I
exactly.
think, yeah.
Mm. But I think centrality and density is a bit different. So if we look at centrality, then every city all over the globe has a diversity of centralities. I mean, it's non-existing. You have this hierarchy of streets. So you have, and I think that you could say something about the mesh of the sort of the foreground network. If that is, we can just make it very concrete. If it's 1 kilometer between one main street and the other main street, or it's 400 meters, or it's 5 kilometers. That of course makes a difference, because if we assume we know also that these main street, they attract more people. There will have the activities, the services, etc. So if they are very coarse, then there will be a lot of people, if there's also high density in between, that do not have access to these main streets with a lot of services. So in that sense, yes, there becomes a mismatch. I think we should more think about understanding the the different requirements that you need to have in a certain distance threshold. Let's say you don't need opera every let's say within 500 meters for everybody. That would be ridiculous. But some of the things we need. So I think it's much more that kind of answer that will give, let's say, that kind of approach that will give you answers and help you in making decisions, than that there is one density or one centrality that is the good one. But for density, there are thresholds, I would say, in terms of, well, if you go too low, you will not have public transport, and therefore you will drive your car, you will walk less. I mean, they're very clear, but where exactly that number is depends also on culture.
Yeah, I totally agree.
So it's, I mean, so there is not sort of this simple one answer to go, but I think that we can come quite a long way understanding the trends and get a little bit more of a understanding of the thresholds for each and every cultural situation. So not the UN Habitat, they had one threshold globally, which is a bit problematic.
Yeah, I completely agree. There are some questions at the Q&A, and then we're going to move to Dr. Muatez, but let's start with the questions. I think from Michelle, if I'm reading the name correctly. If there is a cost to the 1-year license, particularly if it's from a practitioner, she's talking about the last calculator, urban calculator.
Yeah. We have, let's say, there are also universities that want to have a license for the students in studio courses. I suppose it's that kind of question, or for research. So then we have an academic discount, and that is we can discuss.
There's another question from Sohar, if I'm reading the name correctly. I'm so sorry if I'm reading wrongly. Can you please give examples of clients and projects that have used the tools in design and planning practice, especially outside of Sweden? Meaning if it's like having different places rather than just from the European point of view. So they're just asking about this point.
Yeah, I mean, that's always hard because you don't really know. Let's say PST especially, it's out there on GitHub and everybody can use it. We know it is used a lot. We also know that it is European centered. I know, but I think in China a lot is happening. In the African countries, I know there are a few groups active like yours, but there are a few more. But I don't really know, to be very honest. I know and the same goes for Spacematrix, which is not a tool. Let's say like it's more like a method and a model that you can use. But that one it is used, let's say, in many places. I come across it like I don't know anymore. It's used in very different contexts. So it has been tested in Asian countries. It has been. So I think it's widely applied, and I know that the PST, so the things that you can analyze there and how it is tested in different contexts. If you go to the Space Syntax conferences, I mean, these theories and methods, they are used all over the globe. But I was a bit sort of, when I did my systematic review on density impacts, one of the, if you read that paper, you will see it. We could compare density impacts from an Asian perspective, the North American perspective, and the European perspective. But for the others, there was not enough, not enough papers that addressed the other continents, which is very problematic. As you say, in the African continent, I mean, these cities are growing extremely fast. Of course, we have to understand the impacts. This can be like my inability of reading French, etc. So that can be the reason that I didn't find those papers. But it's worrying, I thought.
Actually, I had the privilege of using the PSD from a workshop from the last Space Syntax symposium. So it was really interesting. I've used it. It's really interesting.
Good.
And
Good, nice.
maybe let's go to Dr. Mu'taz, and then going back to the Q&A. Dr. Mu'taz would like to address your question, please.
Thank you very much, Dr. Harib, and thank you, Meta, for this nice presentation and really useful. My point is about the evidence-based and the dynamism of data. So if you are talking about the dynamic and the changes which happens over time in terms of even density measures, so how can you really manage? Because I got the impression that your models are fixed, you know, so
Yeah.
I've seen some work of the MIT people who are really dealing with what we call it real-time data. So their modelings are really, you know, on the spot, and they are observing what's going and the changes over time, you know. But what I've got the impression here is that, you know, yours is more the response or the responsive of the model is not there. So can you just reflect on this, please? Thank you.
No, yeah, very interesting question. That's completely true. So you got it correct. There are static. We have static models, and yeah, let's say that depends a little bit what you are interested in what kind of questions you want to answer. So if you, for instance, want to answer questions about this very fast changing aspects in urban life that are, let's say, for instance, what you need if you want to have traffic lights that sort of let's say react on how busy it is in a street, and then you redirect them in another street, and etc. This kind of stuff. Then you need this very immediate sort of feedback. I think for the types of study that I do, you don't, but I acknowledge that you need actually longitudinal data sets. So you need different snapshots to actually draw robust conclusions. But the process that we look into are not that fast changing. So I don't, but let's say, and it's also a choice. It might be so that we in a few years' time will want to move there, but we have until now we haven't done that. So the next step we want to do is to do, let's say, looking over time. But then it's about these bigger changes in the built environment. It's like adding a new neighborhood or adding new streets. It might also be that I'm kind of biased by the European context, where these changes don't occur so fast. Can absolutely be. I don't hear you. You're muted.
Sorry, I need to unmute him. Yes. Yes, go ahead. Yeah.
Okay. Because the one thing is that, for example, in Cairo, for example, if you look at a city like Cairo, for example, you'd see that, you know, over you know, between day and night, you know, there's changes in density. So how this would impact, you know, the context and the design of the space itself, you know, and the plan
right.
as a whole.
Yeah. Okay. So I mean, we have done. I didn't show you, but we have done this fluctuation. Let's say the fluctuations over time for over a day or a week or a month.
Yeah.
In terms of pedestrian movement patterns, that we have done. And what we actually found there is that the magnitude, so the amount of people, fluctuate enormously, but the patterns are very similar. So the sort of the most central streets with the highest density have always the highest amount of people, although it drops at night and it peaks at the lunch hour, for instance. But the patterns are similar. So we have done a few of those studies where we actually have measured, let's say, so this study that I showed you in Stockholm, Amsterdam and London, we did it was a 24-hour cyclus. And then we have other areas where we have a week cyclus, or so we have done a few of those. Okay. Because yes, of course, yes, it fluctuates. And if you would do, I mean, also for the biodiversity, let's say, there's also season fluctuations, etc., etc. So of course, yes, these are important.
Thank you, Dr. Mu'taz.
Thank you.
Thank you. Thank you. There's a question from Soharb, if I'm correctly pronouncing it. She's discussing things regarding ecology. Is there a method you know of determining the bar minimum ecological needs or benchmarks across contexts? And broad question, but maybe you can point to a book or a paper that discuss this. If you have a
I mean,
reflection.
it's very, let's say, from an ecological perspective, you need to have, it's very, it's even more context specific, I would say, let's say. So you need to know, if you are working with a specific city, you need to know what are the key species there that you need to sort of take into account. And those have a set of key biotopes that you need to consider. So you need to have a bit of a knowledge of your location, your city, your region that you work with to be able to answer that. What we are trying to do in our research now is to actually establish it, what you in a way are asking for. Can we, because this is kind of annoying from an urban planning and design perspective, because you don't know, and so can we identify those biotopes that are important for all different kinds of species that are, let's say, that are found in cities in general. And maybe we should have a sort of a set for different climate zones. There can be a bit of that variation. So we want to generalize this, but haven't gotten there yet. So now it's very often that you go, that let's say if ecologists are involved, they go to find the key species. It's in a way you can think about it like this. What they try to do is to find if a city is walkable for a child, it's also walkable for an adult. So in a way, you find these species that are kind of, if you solve it for those species, you solve it for many. So that's what's called key species. So that's a shortcut already, but we want to sort of go to what are the environmental demands or the natural environmental demands of those, and can we generalize that in our models?
Yeah, thank you. We have like nice questions actually, but I need to choose from them because of the time.
Yeah, yeah.
I think there's a question here from Dr. Ahmed Rafat, or Rafat. It's about asking, is the proximity analysis depends on topological or metric notion of distance?
You can actually choose. So what we often also do is that you can do both. And then the topological distance says something about let's say the effort to find it, while the metric is the physical effort to get somewhere. And you can compare those two maps, which is kind of nice, because sometimes it's not far, but it's very hard to get there. The orientation, let's say so it's a left turn, a right turn. It's like if you ask, let's say someone asks you the way to the bakery, and then you start explaining, and if you have to say 3 times left and 4 times right, everybody will get lost. He will not remind, let's say, but if it was only 1 turn left and then you are there, it's fine. Metrically, it could be as far. So so you get kind of, if you have these two perspectives, it's very nice to compare them, and you can run both in PST.
Here, there's a question regarding the application of the place semantics tools about informal settlements or informal neighborhoods, because they might have different morphology.
Yeah.
Do you think that it would work the same like the formal one or the regular one? I mean, like having an organic structure versus the typical one or gridiron one?
Yeah, I mean, it works in similar ways. It has also been applied. Not by us, not by our group, but I know that it has been applied by many others. The thing is, of course, that the data is often not so easy, not always available. But also there are papers written. I can mention that we have one project. I mentioned it in the beginning, but I quickly went through it. So it's called the Twin to Expand project. You can find it on our website. And there we are actually also looking into data scarcity and how to have methods to come across that and still being able to do all these kind of advanced analysis. So that's specifically looking into that, and how more data light models, how well do they perform in comparison to more complete models. And this is ongoing work, but we have, I think there was one paper at the Space Syntax conference last year about that. So that's interesting to look into, because that has, let's say, this idea that indeed, okay, if you go to an area like an informal settlement where nothing is available, what do you do then? How can you still use this kind of analysis? Because the results of these analysis will be as relevant there. The thing is that it's more harder to get those results.
One last question, because I know that we have taken a lot of your time, valuable time. Regarding new fresh graduates that would like to go to be postgraduate students, what sort of an advice to them to gain what sort of skills? Because being an architect alone or being an urban designer alone, I think it's not enough at this time, or this, I mean, like with the existence of an AI, existence of they need to have some sort of programming abilities and so on.
Yes.
So from your point of view, what sort of skills the fresh graduates needs to get?
Yeah, I think it's the combination of let's say more sort of urban design, architecture, urban planning, that let's say to know what is needed. One.
Yes,
As a no, but I think as a researcher, you also need that, an understanding of what is, let's say from my perspective, if I have someone in the group, that in combination with a good understanding of urban morphology, because not always that is sort of, you have that if you are an urban planner or a designer. So urban morphology is key to understand, let's say, what are the elements, the components, and what are they composed of? How are they? So that's very important. And then we have the digital innovations, let's say. It's you have to be able to GIS, of course, core programming. Python is I think all my researchers and they use it. It's kind of key. When I was a PhD and I did in the beginning my research, I didn't use that, but currently that is what you have to be able to do. And AI is part of that. It's already that's already used quite a lot, and it's not. I don't see that. I mean, it's a huge jump in terms of that you can do big data much faster, etc. But it's not a huge shift in how we work at the moment. But those are the three packages, I would say. Knowing for whom we are doing it, having a good understanding of what we are actually describing, so urban form, and having the toolkits to be able to analyze and work with it in an advanced digital way.
That's brilliant. Thank you very much. Thank you for your time, and thank you for the participants for their lovely questions. I'm so sorry if we didn't address all the questions, but really it was an interesting, valuable webinar. And with your consent, if you give us, we're going to publish this webinar with some sort of like a summary for it using AI. Sorry.
Yeah, yeah, that's fine. It's good for that.
And thank you very much, and looking forward for any future collaboration. It's going to be really our interest and our pleasure, of course. Thank you very much, and thanks for all the participants being here with us. Thank you.
Thank you for the invitation.
Yeah, thank you.
Bye-bye.
Bye-bye. See you.